Solar energy, a growth market with countless opportunities. As more and more countries recognize photovoltaics as a pillar of their future energy supply, the number of cost-effective multi-megawatt PV power plants is rising. In this highly competitive market, investments are not without risk. But how accurately can we predict the yield? And how can we be sure that a power plant will actually generate the predicted yield once it's in operation? Quality assurance PV modules and power plants. This is both the name and mission of our department at the Fraunhofer Institute for Solar Energy Systems, ISE. From planning through to long-term operation, we offer the full range of services for a comprehensive, precise and independent quality assurance. We support our customers all around the world. We have successfully completed projects in countries including the USA, Chile, Brazil, China, India and Pakistan. The scientific network within Europe's largest solar energy research institute brings our customers a unique added value. PV power plants around the world are exposed to harsh environmental and climatic conditions, such as soiling, extreme temperatures, or severe fluctuations in temperature, high humidity, and varying regional irradiation levels. In any PV power plant project, such location-specific requirements need to be clearly identified and integrated in the design from the very beginning of the planning process. Environmental and climatic data from different geographic information systems provide us with important information, and we also draw knowledge and experience from our own monitoring projects. At Fraunhofer ISE, we prepare independent and highly accurate yield assessments which take into consideration location-specific irradiation, equipment design and customer-specific parameters. Since our services improve investment security, many investors explicitly ask for our yield assessment reports. We start by looking at system details and documentation. We know exactly what we're doing when we do simulations because we design the simulation software ourselves. We calculate P90 values based on model uncertainties, which are neither uniformly nor normally distributed. Fraunhofer ISE is the only institution that's able to offer this. Using our own simulation programs, precise predictions are calculated for solar radiation. Not just the front side, but also the rear side of the module, which means that the yield can be accurately predicted even for bifacial PV modules. This allows taking into account other parameters such as shading, reflection and inclination angle, specific characteristics of the modules. This is how we create accurate yield assessments, as well as studies on the yield optimization of both projected and existing plants. The quality of components is the key to obtaining highest possible yield. At Fraunhofer ISE, we have developed a quality benchmarking test program specifically for this purpose. The aim is to test the quality of modules and components and their suitability for the planned project before procurement. Our accredited calibration laboratory, CalLab PV modules, with an uncertainty of only plus or minus 1.6%, one of the best laboratories in the world, carries out performance-related measurements for quality benchmarking and the accurate characterization of modules. The energy rating also provides highly accurate input parameters for use in yield assessments. One of our USPs is that we can characterize a very high number of solar modules with highest accuracy and within a very small time frame. CalLab PV modules takes a step beyond measurements under standard testing conditions or STC by offering comprehensive characterization of solar modules for our customers' actual operational requirements in the field. The quality benchmarking testing also includes reliability and material durability tests, which are performed in our accredited testing and certification laboratory, TestLab PV modules. Systematic performance, reliability and material durability tests in the procurement phase increase safety. Our proprietary selection method makes our random samples highly representative. The procurement check is performed in our service labs. The durability of the modules in varying climate conditions, including heat, cold and humidity, is tested in different environmental test chambers. Various test methods allow us to examine the selected module's sensitivity to cell cracks and potential induced degradation, or PID. Another important stage of testing is the mechanical load test, where wind, snow and ice loads are simulated. The module's durability in harsh weather can be assessed with the help of a specific hail test. Visual tests using electroluminescence, for example, provide us with even more information and make even the smallest deviations in the material visible. To ensure that a newly constructed power plant is cost-efficient from the start and fulfills the stakeholders' requirements regarding yield and financial planning, we offer a comprehensive examination of the entire power plant. This entails checking the correct assembly and function of all power plant components. We also ensure that the power plant complies with the initial design. The system is checked for the correct module orientation, environmental parameters and possible shading from internal or external sources. Infrared cameras scan the modules for hotspots, while all cables and fuses are inspected for proper dimensioning. For power measurements, single strings are measured. Module measurements taken at our CalLab PV modules help us convert the measuring data to STC and to assess the module power measured in the field. Important parameters such as temperature coefficients and series resistances are accurately determined. If any discrepancies occur, the final system testing report provides clarification and is generally able to offer solutions and suggestions for improvement. Modules with defects are examined in detail in our precision laboratories. Fraunhofer ISE has more than 10 years' experience with field measurements in solar PV plants. These measurements are characterized by an extremely high accuracy. The cooperation with our colleagues from CalLab PV modules enables us to verify selected measurement results in the laboratory. Actual yields and the interaction between modules and inverters within the overall systems cannot be checked until the system has gone into operation. In practice, one of the most frequently required tasks is the accurate and comprehensible assessment of the performance ratio, or PR, of a PV power plant, either at the time of commissioning, at the end of the warranty period, or in the event of a resale. The Fraunhofer ISE Independent Performance Report can reveal any problems with components, such as modules or inverters, as well as deviations of the overall performance from the expected or forecast performance as shown in the yield assessment. The monitoring period may stretch from a few weeks to several years. We have developed a method which determines the annual performance ratio to a high level of accuracy within a few weeks, which has proven successful in several large-scale projects. Also for this task, Fraunhofer ISE uses only customized measurement equipment which is highly precise and reliable. This reflects our own high standard of quality. Mobile monitoring units can be used for initial short-term analyses on site. Experience has shown that a conclusive analysis is possible within just a few weeks if the plant shows any abnormalities, for troubleshooting or in the case of warranty claims. Predictions are always slightly inaccurate. In new markets particularly, we often have no operating data for PV power plants, and we also have little experience in how much loss to estimate for soiling effects, for example. This is where this type of short-term or long-term monitoring comes in, as it allows us to verify input parameters. It allows us to give investors a yield forecast which takes into account such uncertain factors based on our monitoring data. This reduces the risk investors take when they get involved in a project. Failures observed in the field can be even more closely examined in our test lab PV modules laboratory at Fraunhofer ISE. Our comprehensive analysis methods help us understand failure mechanisms and accurately identify their causes, which means that the errors observed in short-term or long-term monitoring can be eliminated and avoided in the long run. Fraunhofer ISE Quality Circle, expert assistance to ensure a sustainable yield. We've been working with photovoltaic power plants since 1990. Our extensive experience helps us to find the best solution for our customers. We have unparalleled expertise along the entire process chain, from solar cells, solar components, modules and inverters to the overall system. We are highly skilled in both theory and practice. Our engineers work both in the field and in the laboratory. Our experience helps to validate our simulation models. The customers profit from the considerable accuracy of our predictions. The aim of the Fraunhofer Society is to facilitate the technology transfer between science and industry. We always use cutting-edge equipment and a wealth of in-house experience, also in the area of cell technology. This allows us to bring all our know-how to a project and benefit from synergy effects. Our team includes experts who hold many years of experience in assessing and testing PV systems. Also, we have an excellent, highly developed and extremely precise measurement equipment. We operate internationally. A growing number of new markets are showing demand for our expertise. Our quality assurance methods increase investors' trust in the technology, and customers who demand quality are offered better deals by banks and insurances. All in all, we offer technical and economic assessments and certification for entire power plants anywhere in the world. As a global player, our laboratories offer customer-oriented and independent services. The Fraunhofer ISE Quality Circle.